Hi guys, in this video we are going to see about decimation in frequency algorithm, that is DIF FFT, and we are going to do this in comparatively with DIT FFT. So I'm going to show that as well. So in DIT FFT, what we did is, so we take the input sequence x of n, that is scrambled, that is we use a divide and conquer approach. The input sequence will be split into even and odd components, and that will be further split into components, right? This will be the bit reversed order. So this is what we have seen with respect to DIT FFT. We take the input sequence is in bit reversed order, okay? But here when it comes to DIF FFT, it's quite the opposite. We take the output sequence, we apply the divide and conquer approach on the output sequence. So the output sequence will be in the bit reversed order, whereas the input will be in normal order. So using this, we come upon the we do the derivations, and we come upon the butterfly diagram, right? So I'm skipping the derivations. Now again, seeing the features of DIFFT, again let us compare it with DITFT. In DITFT, as you have already seen, the input will be in bit reversed order, whereas output will be in normal order, okay? But here it's quite opposite. Input to DIF FFT will be in normal order, whereas the output will be in bit reversed order. So the input, we are not going to do anything. Whatever the order is given in the problem, that we are going to substitute directly, but the output we are getting will be in a bit reversed order. That is the primary difference. And coming to the butterfly diagram, so this is the butterfly diagram for DIT FFT. So the multiplier, that is the twiddle factor, will come before the addition. So we have an x here, the dots represent addition. So here it will be a plus b into wn plus k. B into wn power k will come here. So a plus that value. Similarly, when denominator a plus, the dot represents plus, but here b into wn power k into minus 1, hence it becomes minus wn power k. Okay, so the multiplication comes before the x, whereas in DIF FFT it's the opposite, right? So here there is no multiplication. So here we are having a b, so a plus b, and denominator a, again b into minus 1, so that becomes a minus b. That answer is multiplied with wn power k. So the multiplier occurs after the x. So a minus b I am putting inside a bracket. The answer will be multiplied with wn power k. This is another difference, right? So the multiplication occurs after addition. So this is the difference. It's quite the opposite of what we did in DIT. Okay, so suppose in DIT we are going for an 8-point DFT. What we do, first we compute the 2-point, then we go for 4-point, then we go for 8-point. So here it will be the entire opposite, right? When we need an 8-point DFT, first we will start with 8-point, then we will go for 4-point, then we will go for 2-point. So you will understand it more clearly when we solve the problems. So for these 3 points, when you compare it with DIT FFT, you will understand more clearly. It's the exact opposite of DIT FFT, but the end solution is going to be the same. We are going to calculate FFT. So whether you use DIT FFT algorithm or DIF FFT algorithm, the end answer is going to be the same. Only the approach is different. Okay. So now we will start a problem. As usual, we start with a 2-point DFT. So let me take the sequence. X of n is equal to and 1 and 2. Okay. So we will just have 1x, 1 and 2 are the inputs. Here it is minus 1. At the output there will be multiplier. Since this is a 2-point, the multiplier will be w2 power 0. The answer will be 1. Okay. So in this plus we will get 1 plus 2, 3. And here 1 minus 2 into 1. So minus 2. So 1 minus 2 multiplied by 1. So the answer will be minus 1. So the answer x of k is equal to 3 minus 1. So here this is just x of 0, x of 1, and output capital X of 0, capital X of n. There is nothing to do on bit reversal. So the 0 is represented in binary as 0, 1 is represented as 1. So since we are using only one bit, even if you reverse the bits, again it will be the same. But when it comes to 4-point, you have to check the bit reversed order. So we will do the 4-point sequence now. Okay, so we will take the sequence x of n is equal to 1, 2, 3, 2. Okay, 1, 2, 3, 2. So this is x of 0, x of 1, x of 2, x of 3. So 4 points we are having. So let me draw 4 lines. So now you have to carefully understand the difference between DIT and DAF. So the input is going to be in normal order. So x of 1, x of 2, x of 3. So you can substitute as it is given in the problem. No need for bit reversing at the input side. So what we did in DIT, we start with 2 point, then go for 4 point. Here it is the exact opposite. We start with 4 point. So first we combine the first and third line. Okay, the lower branch will have a multiplier, minus 1 followed by a multiplier. So the multiplication comes after dx. So since this is 4 point, w4 over 0 equal to 1. I hope you get it. Now we will compute the answer. Here 1, here we are getting 3. So 1 plus 3. 1 plus 3 is equal to 4. Okay, denominator 1 minus 3. So 1 minus 3 is equal to minus 2. Okay, so here we will rewrite the answer. Right, so the 4 comes here, 1 minus 3 minus 2 comes here. Okay, now go for the next x. Denominator will have a minus 1 followed by multiplier. So this is a 4 point. We have already written w4 power 0. This is the second x. So we have to write w4 power n, w4 power 1, which is equal to minus j. So this expression we have already seen in DIT. It's the same thing, right? W4 power 1 is minus j. So now let us calculate 2. From denominator branch we are getting 2. So 2 plus 2 is equal to 4. So here we will get 4. And here 2 minus 2. Okay, 2 into minus 1. So 2 minus 2 equal to 0. So here 0 into minus j. So 0 into minus j, the answer will be 0. So this is the input to the next stage. I hope you understand. So in the lower branch, whatever output we are getting from addition or subtraction, we have to multiply with the multiplier. Since it is 0 here, when we multiply with minus j, the complex number is getting disappeared, right? In other scenarios, we might get the complex numbers. Now we go for 2 point, right? So this is 1 2 point minus 1, and the output is multiplied with w2 power 0. Since it is 2 point, w2 power 0. Okay, so 4 plus 4. 4 plus 4 equal to 8. And here 4 plus 4 into minus 1. So minus 4. So the answer is 0. Then the next 2 point. Minus 2 plus 0. So minus 2 plus 0 equal to minus 2. And denominator, the minus 2 comes as it is minus 0. Okay, so the minus 2 minus 0. So it is minus 2. Now here comes the important part. This is in bit reversed order. Remember, x of 0, x of 2, x of 1, x of 3. So I have already shown you the bit reversed order in DIT. So this is the bit reversed order for 4 point. The normal order is 0, 1, 2, 3. Whereas the bit reversed order will be 0, 2, 1, 3. So x of 0, x of 2, x of 1, x of 3. That is what I am written here. Capital X of 0, x of 2, x of 1, x of 3. Now while writing the answer, we have to write it in the perfect order. So first x of 0, that is 8. Then x of 1 is minus 2. X of 2 is 0. And x of 3 equal to minus 2. So this is the answer. Hope you understand the difference. So when you solve a couple of more problems, you will be more clear with the ideas. So the difference is entirely opposite of DIT. Okay, there we started with 2 point, then we went for 4 point. Here we start with 4 point and go for 2 point. There the multiplication came before x. Here the multiplication comes after x. There the input will be in bit reversed order, output will be in normal order. Here the input will be in normal order and output will be in bit reversed order. Thank you.